Example A, page 68, number 3. Given side lengths 3 inches and 6 inches, provide the minimum and maximum whole number of side lengths that determine a triangle. So your steps to do this: first, you're going to go through and add the two sides together to get your max. So I'm going to add 3 plus 6, and I get 9. So that means that since we're looking for a whole number side length here, the biggest it could be is a number that's less than 9. So you have to think, well, what's the next whole number that's less than 9? 8. So the maximum side length is 8. Next, to find the minimum, you're going to subtract the two sides. So second, subtract. You're going to take 6 minus 3, and you get 3. So when you're looking at the minimum, the smallest it could be is a number that's greater than 3. And again, since this problem gives us a requirement of having only whole number side lengths, if you're looking at a number greater than 3 that's whole, it would be 4. So your maximum side length is 8, your minimum side length is 4. Now, just to talk about where these numbers came from again, let me give you some more information on this. So if we're looking at the possible values for that third side, here's a little diagram of what's going on here. So we have 3 sides. The one's drawn on the paper. Let me just fix this, make this straight. So we're given the 6 inches and we're given the 3 inches. Here's my 3 inches. I'm going to first start by extending this all the way this way. So if this was a straight line, meaning it was not a triangle, if it was just a straight line, this third side would have to be the total length. 6 plus 3 is 9. So in order for this to be a triangle, this third side has to be less than 9. So if I move this third side up a little bit, so it's no longer just going straight across in a straight line, you have a number that's a little bit less than 9. Okay, so that's why our maximum value, we chose a whole number of 8, because you had to have a number that's smaller than 9. Now on the other end, when looking at the minimum, if I go and bring this all the way straight so it's lined up this way. So what do I need to add to 3 to get 6? 3. So if I had exactly 3, the two sides would touch. 3 plus 3 is 6 exactly. So I need this to be a little bit bigger than 3. So they meet somewhere up here. So here it's a little bigger than 3. If it were at 4, it would look something like this. Okay, that's actually the minimum value we had when using the whole numbers. If it was about 5, it looked like that. 6, 7, and 8. So you see the various triangles. But if you notice, you had to have a number that was less than 9, but greater than 3 to make this triangle. Now, if you want to go further with your answer, you could explain this in symbols if you want. If you're talking about that third side, the third side had to be a number somewhere between 3 and 9. And then if you want to talk about this in words, you could also talk about this in words a little bit. You could say the third side is between or is greater than 3 and less than 9.